Welcome to this detailed explanation of the face mask detection using CNN project. In the wake of the COVID-19 pandemic, ensuring whether people are wearing masks correctly became a major public safety challenge. Manual monitoring is difficult, time-consuming, and often unreliable. This project brings an automated, AI-driven solution using deep learning and computer vision to detect whether a person is wearing a mask or not. Face mask detection plays a critical role in public health monitoring. This system uses a convolutional neural network, or CNN, to classify faces into two categories, mask and no mask. The dataset consists of hundreds of labeled images of real people, both wearing masks and without masks, captured in different lighting, angles, and conditions. This helps the model learn robust patterns and perform well in real environments. The objectives of this project include building a CNN model capable of accurately identifying masked and unmasked faces. Other objectives include pre-processing and augmenting the dataset to improve generalization, implementing real-time face detection using OpenCV, and testing the system using webcam snapshots in Google Colab. Finally, evaluating accuracy, precision, recall, and performance metrics is crucial. The project follows a clean and systematic workflow, starting with dataset collection. We use the Kaggle face mask detection dataset, which contains diverse samples under different lighting, ethnicity, and pose variations. Step 2. Data preprocessing involved resizing all images to 128 by 128 and normalization. We applied augmentation such as rotation, flipping, and zooming to prevent overfitting. Step 3. CNN model design involves multiple convolution layers for feature extraction, pooling layers for dimensionality reduction, and dense layers for final classification. The output layer uses a sigmoid activation function for binary classification. Step 4. Model training was conducted for 15 epochs using Atom Optimizer and binary cross-entropy loss. Training, validation, and testing sets ensured fair evaluation. After training, the CNN achieved 97% training accuracy, 95% validation accuracy, and 93% test accuracy. These results show strong generalization with minimal false positives and false negatives. The accuracy graph displays steady improvement over epochs, proving successful model learning. The model was integrated with OpenCV for real-time detection. Because Google Colab does not support direct webcam video, a JavaScript-based snapshot system was created to capture images from the user's camera. The system detects faces using Haar cascades, draws a bounding box, and adds a prediction label like mask, 99.9% confidence, or no mask, 92.3% confidence. This makes the system ideal for automated security and compliance applications. This face mask detection system has numerous real-world applications, including surveillance in airports, malls, hospitals, and schools. Other applications include smart access control at building entrances, public safety monitoring through CCTV, IoT-based health monitoring systems, and smart city surveillance infrastructures. Anywhere mask compliance needs to be monitored, this system can help. The project can be enhanced by detecting incorrectly worn masks and combining mask detection with temperature screening. Future improvements also include running lightweight CNNs on edge devices like Raspberry Pi, adding dashboards for live monitoring, and training on even larger and more diverse datasets. These upgrades can improve accuracy and usability in real-world environments. In conclusion, this project demonstrates how deep learning and CNNs can be used to create an efficient, scalable, and reliable face mask detection system. It performs well in real-time conditions and can be deployed in various public safety scenarios. This project not only solves a relevant real-world problem, but also serves as an excellent learning model for deep learning, image classification, and computer vision. Thank you for watching this detailed explanation of the face mask detection using CNN project.